Earlier this month, the U.S. Navy carried out a successful demonstration of an advanced standoff strike capability designed to significantly increase the reach of its carrier-based fighter fleet. The test involved a new munition known as the GBU-75 Joint Direct Attack Munition Long Range, JDAM-LR, which was deployed from an FA-18 Super Hornet during trials conducted over the Point Mugu Sea Range in California. The JDAM-LR represents an evolution of the well-established JDAM family, transforming the traditional guided bomb into a cost-effective, precision-guided cruise weapon. It integrates the extended range wing kit from the JDAM-ER, featuring deployable glide surfaces, with the addition of a compact turbojet propulsion system, enabling sustained powered flight and significantly greater standoff distance. In this video, Defense Updates analyzes how JDAM-LR is set to provide U.S. military with cost-effective long-range strike option. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. During the April 1st evaluation, an FA-18 Super Hornet deployed the munition, which reportedly covered approximately 230 miles, 370 kilometers, in 34 minutes and impacted within meters of its designated target, according to Boeing. A subsequent test on April 3rd executed a second pre-planned flight profile, incorporating altitude variations and weapon maneuvering, while other aspects of the mission remained largely unchanged. Captain Sarah Abbott, the program manager, said the capability allows pilots to engage targets from significantly safer distances, maintaining a tactical advantage in contested environments. In a company statement, Boeing noted that the extended range configuration offers a cost-effective solution for long-range strike missions while leveraging existing inventories. Boeing's Bob Ciesla, Precision Engagement Systems Vice President, said in a statement, "This weapon brings the cruise missile concept to the JDAM family at a lower cost, enabling large production quantities." The JDAM-LR program is now advancing through further testing and integration activities as the U.S. Navy progresses toward operational deployment of the system. The Joint Direct Attack Munition, JDAM, is a modular guidance kit developed by Boeing to convert conventional unguided bombs into all-weather, precision-guided munitions. By integrating satellite-based navigation with inertial guidance, the system enables standard gravity bombs to accurately engage designated targets with a high degree of reliability. The JDAM kit comprises several core elements, including a tail assembly fitted with aerodynamic control surfaces, a strake kit mounted along the bomb body to improve stability and lift characteristics, and a combined inertial navigation system, INS, integrated with a GPS guidance unit. Collectively, these components enable the weapon to correct its flight path and home in on assigned coordinates after release. Following separation from the launch aircraft, the munition autonomously navigates toward pre-programmed target coordinates. These coordinates may be uploaded prior to takeoff, updated in flight by the aircrew, or generated dynamically through onboard sensor-based target designation. Depending on release parameters such as altitude, airspeed, and configuration, a standard JDAM can achieve ranges of up to approximately 15 miles, 24 kilometers, while the extended range JDAM-ER variant can glide to distances of up to 45 miles, 72 kilometers. The turbojet-powered JDAM-LR represents a significant advancement, offering substantially greater range compared to earlier variants. This iteration incorporates onboard power generation, enabling the integration of a two-way data link and advanced seeker technologies. These enhancements improve targeting flexibility and accuracy, including against mobile targets and in electronically contested environments. Additionally, the JDAM-LR retains compatibility with aircraft already certified to deploy JDAM munitions, simplifying integration and deployment. In effect, it transforms the JDAM from a relatively short-range, stand-in weapon into a true standoff strike capability. The JDAM-LR is currently being developed in two primary configurations. The baseline variant is a 500-pound class munition built around the Mark 82 general-purpose gravity bomb. Powered by a single TDIJ-85 turbojet, it is designed to engage targets at ranges exceeding 345 miles, approximately 555 kilometers. A second configuration is optimized for decoy operations. In this version, the explosive payload is replaced with an auxiliary fuel tank, extending the system's range to beyond 805 miles, nearly 1,300 kilometers, and enhancing its utility in deception and saturation roles. In addition to these, two further JDAM-LR derivatives are under development: the Quick Strike Long Range LR mine and the JDAM-LR Maritime Strike Weapon. The Quick Strike LR mine represents a propulsion-enhanced evolution of the existing Quick Strike ER. It is based on a 2,000-pound bomb fitted with the Mark 57 target detecting device, a sophisticated fuse capable of detecting nearby vessels, classifying ship types, and counting transits before initiating detonation under pre-programmed conditions. Details regarding the JDAM-LR Maritime Strike Weapon remain limited. However, it is likely derived from the Air Force Research Laboratory's QuickSync concept. This configuration integrates a JDAM-based munition with both a radar seeker and an infrared electro-optical sensor, enabling autonomous identification of maritime targets. The weapon is designed to strike vessels along the hull below the waterline, a vulnerability that allows even large warships to be disabled or sunk with a single hit. In contemporary high-intensity conflicts, inventories of long-range precision-guided munitions can be depleted rapidly. These systems are not only expensive, but also constrained by relatively long production timelines. Russia's experience in Ukraine illustrates this dynamic, prompting a shift toward a blended strike approach that combines unmanned systems, glide bombs, and long-range missiles to sustain operational tempo while managing costs. The United States is encountering similar pressures. The Trump administration's fiscal year 2027 budget request allocates substantial funding to expand stockpiles of the Precision Strike Missile, PRSM, which has been employed in ongoing U.S. operations against Iran. This request reflects growing concern that sustained operations in the Middle East are eroding critical munitions reserves. Notably, the PRSM was originally developed with Indo-Pacific contingencies in mind, and analysts have cautioned that excessive expenditure in other theaters could create capability gaps in that region. Within this context, the JDAM-LR emerges as a relevant capability. Designed for extended standoff employment, it enables launch platforms to operate well beyond the effective range of adversary air defense systems. This in turn allows non-stealth fourth-generation aircraft to prosecute targets within contested airspace while minimizing exposure to interception risks. Although the unit cost of the JDAM-LR kit has not been officially disclosed, estimates suggest that a complete configuration, including the warhead, could be priced below $200,000 per unit. This positions it as a significantly more economical option compared to systems such as the PRSM, which typically ranges between $1.6 million and $3.5 million, or the Tomahawk cruise missile, which is generally estimated at $2 million to $3.6 million per round.